Okay. Welcome again to CakeFest. I'm going to talk about advanced querying with CakePHP 3. This is going to be very familiar talk to the people that came into the workshop. There are going to be plenty of similar examples, but for people that was not here, this is probably going to be new. And either ways, is a very exciting talk for me to do. So today we're going to talk about a very short story of how the ORM came to be. And the most important for me is that I can transmit the philosophy behind the ORM. If you understand the philosophy, you will probably enjoy and take the most out of the ORM. It will take a bit of time to get used, if you come from K2, to get used to the new ORM, because it has a very different way of thinking, even though it has a very similar array of concepts that we use. And inside that philosophy, I will talk a bit about the goals of the ORM. Then I'll show you some very simple querying examples using SQL Functions, Subqueries, working with associations, and so on and so on. So let's start with a short story. And well, once upon a time, there was a framework that you call recursive tree and then final, and then it brought all the associations in the world. And it was good, and there was much rejoice, and then much pain. Okay, you know that framework? I think we have talked a lot about this story. The old ORM served a purpose for a long time, but I think it's time to change, time to embrace the new features of PHP, and well, to incorporate all the learnings that we have had in these 8 years. So the philosophy behind the new ORM, and as I tell you, it's important that you get behind this idea. If you get it, what we're trying to do with the new ORM and how it's supposed to work, you will effectively you will use effectively all these features and not try to fight them or try to make them something they're not. So the first idea in this philosophy is that the R in the ORM is very important. And in 2010, this is how, for me, the new ORM started. MongoDB was super popular. So I said, oh, I'm jumping into that. So I wrote a plugin for CakePHP to connect Doctrine, Mongo to CakePHP, and I made a very cool application, and then this conversation happened. Boss, hey, can you get the last workshop attendees' email addresses? Sure. Wait a minute. I need to write a MapReduce job for that. So that got me thinking for a long time. Working with data should be easy, right? For MongoDB, it was super easy to put data in, but it was impossible to get it out. And or you had to kind of think of very interesting ways of managing your data and duplicating your data in order to make it easy to get it out. So, yeah, answering that question took more than a minute, and it was too much for me. So that got me thinking, and I thought that, well, relational databases are not going anywhere anytime soon. They've been here since the 70s. They're a real solid, proven product. There's a lot of math behind that, and it's very hard to beat that. They're extremely efficient. SQL is a really great language for getting data. Anyone can understand SQL. You don't have to be a programmer to understand it. So it has a lot of advantages that you should appreciate. So, well, with these ideas in mind, I said, okay, I want an ORM that doesn't go too far away from SQL. I want an ORM that doesn't abstract everything of a relational database away and say, okay, I'm going to be an abstract data source access system where I can go to a database like Postgres, but I can also talk to Mongo. Because they are so different, those two type of databases, those two type of data stores, that it makes no sense. It's kind of silly to say that the database is just a read, write, update, and list set of operations. Databases are so rich in the amount of operation they can perform that it's very silly to just imagine a product, a library that would abstract all those features plus the features of a very different type of database. So, what this means, that no, the ORM cannot connect to anything that is not a relational database. And because of that, we can make great use of all the relational features of a database and expose APIs and expose functions that will allow you to access those advanced features. And it also means that it's not an incomplete abstraction. We try to incorporate most of the commonly used features and also the advanced features of relational databases. What this does not mean is that CakePHP 3 is unable to connect to a NoSQL storage. In fact, there are some plugins that started already for connecting to stuff like Elasticsearch. And connecting to Redis is, well, just a matter of 2 lines and just using directly the Redis class, for example. And this also does not mean that you will spend a lot of time scratching your heads trying to understand how our library, our ORM, will connect to Mongo and translate from one operation, call it upsert, for example, in Mongo, or call it MapReduce, to that thing. I'm not sure if anyone had a bad experience, for example, using Doctrine, ODM, or any other Mongo abstraction library where you start like, okay, what is the equivalent call from this to that in Mongo? Anyone had an experience similar to that? Yeah, I guess so. So the goals we had in mind. First, we wanted extremely clean layers. So I started with the idea that each block in the ORM should be usable on its own. So for example, a connection class would be able to be used by itself. So you connect to the database and you can immediately start selecting stuff. And that's actually true for CakePHP 3. You just say new connection, and even though you're not using the ORM, as in the object abstraction part, you can start selecting. Kind of like a PDO, but it abstracts all the derp features of PDO that makes it impossible to use. Well, that's what the connection object does. And the other goal was that each one of the blocks should sit on top of the other without depending, the ones below depending on those above. So as you can see in this case, I can use the table registry, which is a class we're going to talk about it later, and do a find. What find does is actually create a connection and do a similar query to that you see there. Another of the goals was that we should have an extensible column type system. So you want enum, you can use enum. You just need to create the enum type class and just tell a table that you want to use a specific column as an enum. We don't have enums. Now, we don't support them in CakePHP, but if you want that, you can use it. Do you want a JSON kind of column? You can use that. Do you want a money type of column like in Postgres? Do you want a geometric type? You can do it. Another goal was that lazy almost all the things. So the ORM or the connections or any block in the system should not do more work than it is supposed to. So for example, in the first example of code, I'm not sure if you can read it there. Is it readable? Yes? There are absolutely no SQL queries done there. Even though you're telling it to find all and you're adding some conditions, it's not doing anything. At most, it's connecting once to the database to get the table schema. In the next request, it won't do that because schema is cached. So generating queries is actually very fast because it doesn't have to go back and forth with the connection. And the second example, you can see that it is actually executed because you're telling the query, hey, give me all records. And in the third example, which has at the end buffer results false, you're telling it to not store in memory the previous rows that it has fetched. So it's lazy in a way that you can stream millions and millions of rows without consuming all PHP memory, if you need that. Another goal is that it should be super fun to work with. I really have hard times working with software that makes it difficult. And I say, well, I work with CakePHP every day. I know there are plenty painful points. I don't want them there anymore. The ORM should be fun to work with. It should be at most 3 lines to answer any question or difficult question in the ORM, with the ORM working with the data. So it's fun because everything is an expression. So as you can see, I can chain all the methods, find, select, where, order, group, and I can use each part of that query to compose other queries. So for example, I have here a inner join stuff query in the 3rd line. So that means that I'm doing an inner join with a subquery. So I can build queries and pass them around seamlessly. So everything works as an expression. And in the second case, you can see that queries can be composed. So if you have a custom finder called active, I can again chain it and say, well, everything that active does, then append everything that find premium does, and then for each user, echo the username. So each and other functions that we're going to look at later are part of an object called collection. So queries also work as a collection. And in the last example, we can see that we find some recipients, find active, then append, find subscribe to newsletter, and then from the first query that we did in the previous example, we can say premium append the results from other query and then extract the emails of those. So as everything is a expression, I can even append results from multiple queries. So let's jump to the examples. This is a simple setup. I'm going to create a countries table. This is try to think of a world database. We have countries. Countries have capitals. Countries have many cities. And countries has many languages. Okay? So an example of a simple query. Find the biggest monarchies. So as you can see, it's only 3 lines. It's quite easy. This is the way CakePHP 3 allows you to generate custom finders. You just have find, then a camel case name of the finder. It gets a query, and you just return a query. You have always, or you are required to return a query, not a single result. So well, it's query where government type like monarchy, and then order by population descending, and this is the result I get. I get the biggest monarchies in the world. That's very simple. So what are the biggest or the republics in the world? Well, is return a query where government form is republic, or where government form is federal republic. So you can chain conditions as long as you like, using where, or where, and where, and there are more we can look at later. This is how you use SQL functions. So find the average life expectancy of a country. It gets a query, and it should return a query. And it's quite simple. It's simply selecting a field called average expectancy, which is a query. We use the function average and use the life expectancy column. And this is the result. So the average life expectancy in the world is 66 years. 66 years. Any questions about this so far? How this is working? So how to do subqueries? I'm not sure if you have tried in the past with K2 to do subqueries. They're a bit of a pain to do. There are some plugins that can help you, but anyways, it's always like a hit or miss. Sometimes it works, sometimes it doesn't. You need sometimes to grab it in an expression object, sometimes not. Sometimes you need to add some parentheses, sometimes not. So if you're using Postgres, it gets even weirder because Postgres is very picky about how you quote the columns. If you have too much quotes, it will complain. But in Cake 3, it's not that difficult anymore. So I want to find countries with high life expectancy. And I'm going to define high life expectancy as they are above average. So I need to compose two queries. First, find what is the average life expectancy. That's a query. And then I return a query where life expectancy is more than the average, and then return in descending order. A cool thing about the ORM is that you can combine queries. So I have an example there. So give me all republics that have a high life expectancy. And the result of that is that San Marino, Singapore, and Iceland are the republics that have the highest life expectancy value in the world. So as you can see, with at most 4 lines, you can answer very specific and complex questions with a new ORM. So let's see how we work with associations. You know that countries has many languages, and only one language, or could be more, is the official language in that country. So I will add a new association. In this case, I will assume that there's only one official language. So this has one official languages, and I append conditions. So every time I find official languages, it will add those conditions to the association. Sorry. So how do I find official languages? Well, I create a custom finder, find with official language, receive a query, and it simply contain official languages. That is quite straightforward. Probably you are familiar with that if you're working with Cake 2. So strategies. One cool thing about Cake 3 is that you can change how associations that are fetched. So one way of fetching an association is by joining. So for example, if you use a has1 or a belongs to, CakePHP will join. For example, articles belong to authors, then that's a left join or an inner join. But you can tell CakePHP, hey, I don't want that. I want you to use a select. So first select the article and then select the author. Or if you have millions and millions of rows and you have a has many relationship, for example, you have millions of countries because you're in a big galaxy and there are millions of languages, then fetching first all the countries in the galaxy, fetching the IDs and then passing the IDs to the database to fetch the languages, that will take a long, long time. So you can tell CakePHP, hey, don't do that. Instead of fetching the IDs and then passing it to another query, add the query as a subquery in the next finder. So that can greatly, greatly improve performance when you have a lot of records in your database. In this case, I want countries with the spoken languages in that country, and I'm going to pass an option called language strategy. I'm going to change the strategy on the fly, and then just return the query containing languages. So I change the strategy in the next line. I say, countries find with spoken languages, and the language strategy is subquery. Yes?
Is it reversed after the find?
No, it's not. And I just did that as a quick example, so not to waste too many lines. My recommendation is that you define beforehand what strategy you want to use for that association for the rest of the application. So that actually depends on how many records you have in the tables. If you have a good database like Postgres or MySQL 5.6, using always subquery would be my recommended value. And then, well, you have the SQL that is used. You select star from languages, where country ID, and select all the countries. Filtering by associations. I'm not sure if anyone have had difficult times in Cake 2 trying to get deeply nested data and trying to filter that data by other association. Typical example, get me all the articles that were tagged with CakePHP. That's a very typical example. And it's difficult because it's a has and belongs to many, so you need to go through the join table and also join the other to get the name. In Cake 3, this is extremely easy. This is an example. Give me all the cities that are bigger than Denmark in population. Denmark is a very small country. It's only 5 million people that living there. And there are plenty of cities in the world that are bigger than Denmark. So I was curious and I asked that question. It was super easy to answer. And I get the Denmark's population as a query. And then I return the query. Let's focus on the line that is not yellow. Matching cities. That means basically an inner join with cities. And I use a query builder, which is an anonymous function, where the population is bigger than Denmark's population. So the line that is in yellow is important sometimes because it will remove duplicates that are created by the inner join. So if you're okay with the duplicates, that would be a valid query as well. You remove that line. But if you want duplicates removed, you can say, well, remove duplicates by this condition. The condition is that country's ID should be unique. It's basically like a distinct on if you have ever worked with Postgres. So raw SQL and deep associations. So I want to learn a new language. I don't know anything about the world. I don't have Wikipedia. I only have this database. And I know, for example, I'm going to try to travel to India. I know some people speak Urdu, and some people speak English. But honestly, if you drop me in India, I have no idea if I have to speak Urdu or speak English or speak another of the 100 languages that are there. So I created this query. And I want to go to a city which the probability that that language is spoken is very high. So it's basically a formula where the percentage of people and the probability of that language being spoken is more than 25%. So at least a quarter of the population will do that. I'm doing this very complex example so you can see how this complicated question can be solved in less than 10 lines. So it's basically, get me the query, matching. You can see that is nested associations, countries dot cities. So you're going 2-level deep in inner joins. And then you get the probabilities, just a mathematical formula. You can see that's an example of how to use raw SQL. When you cannot write it with the ORM, you want to do something like that, you use expression objects using new expression. And then finally, for that matching part, for those inner joins, you say, well, select probability as that expression and the city name where the probability is greater than equal 0.25. I know it's complex, but I just wanted to show you like a complex example that can be solved in very few lines. So what about after save? As you can see, you are required to return a query, not results, right? So that seems kind of complex. We don't have an after find callback anymore in Cake 3. So that's going to be confusing for some people. But hopefully, if you are behind the idea, the philosophy of the new ORM, you will understand that everything should be lazy. So don't process the records unless they actually need to be processed. So things to keep in mind. Custom finders are required to return a query. And returning an array or a single value is not a query. Therefore, if you return arrays or any other value from a custom finder, you're going to get a sad face from the framework. So the solution is use one of those two solutions or two functions. One is format results or use map reduce. Or after doing your change of finds, you can use any of the methods in the collection class to post-process the query results. So some examples. I want to find all countries in continent groups. So it's very easy. It's simply the query format results. That means that once a query is executed and once I start fetching the first record from that query, it will do this. It will return results grouped by continent. And that function, group by, is actually a function inside the collection class. So you can treat results as a collection and have a wide variety of functions. If you have ever used, for example, _JS, you will be familiar with this. We have all the functions. It's basically inspired in that library. So we implemented them all. And you have like an example output of that query. You have Africa and the name of the countries and then another continent and so on and so on. So getting key value lists. So I want to find the countries with their official language in a key value list. So it's the same. I return the query and format with the result formatted at the end, where I will combine the name, and as you can see, there's a dot notation there. That means use the association dot language property. And then I finally return another query or another custom finder. And this is a example result of that query. It's basically all the countries in the world with the name of the language that is official there. How do I do multiple formatters? That's also easy. For example, I want to return all countries in regional groups in continent groups. So I first apply a formatter, which is group by continent, and then I apply another formatter, which is for each one of the countries, that would be results map, and that for each one in that map will be a continent, then group again by region. And you get that result. North America, Caribbean, and then each one of the countries inside. We have also some intelligent counts. So for example, I find, and I return a query, the select accepts a closure. Mostly all functions in the query builder accepts a function, so you don't have to break the chaining. So if you need to do complex operations and do not want to break the chaining, you can use a closure. So here I will return the average life expectancy as the other example, grouping by continent. And if I call count in that, that's still a query. There is no in-memory processing. If I call count with that group, it will return 7. If you think about it, that's a complicated thing to do, because I'm trying to get all countries that are grouped by, and then I will count by them. So the correct answer is 7, and what the ORM is doing is actually selecting from the subquery that is generated by the thing above. Why is this useful? Can someone answer? Pagination, exactly. If you have something like a dashboard, you have a sum or a group by of some financial data, and you want to paginate those results, this is perfect. You have to do absolutely nothing to make your complex custom finders paginatable. So, as I say, I have 99 problems, but counting ain't one. As I said before, if you want to paginate something really, really hard, and still doing the intelligent counters that CakePHP offers is not enough. For example, you run YouTube, and you have millions and millions and millions of videos. Doing a count star from videos is quite silly. No one wants to know how many videos are in your search. So you just return an estimate. So you have an estimate in cache of how many rows you have in that finder, and you just return them from cache, and that's it. You have some fake next page finders. Have anyone tried to go very deep in YouTube? It gets crazy. So that's a good solution for that. I don't want to count everything. I just return an estimate. I save a lot of time. And there's also plenty more, but we're running out of time. We also have result streaming, as we saw in one of the first samples. So only one record in memory. I can stream millions and millions of rows. I can cache queries. I have finder callbacks before find. I have behaviors. The ORM supports composite keys in almost every method of the query builder. And we have a big variety of methods for finding inside tree structures. And there's more and more and more. And hopefully you will discover more by talking to us in the next presentations, by watching the recordings from the workshop on what else can be done with the ORM. So hopefully you enjoyed this talk. Thank you for your time, and if you have any questions or want to see the example code and SQL schema that I used for this talk, you can go to that repo. Thank you.